Welcome to this tutorial. I would be solving question number 11 of 2017 May-June paper 2-2, and the topic of this question is the radiations, background radiation and the active radiation. The topic of this question is radiations. Question says one source of background radiation is cosmic rays. The cosmic rays that enter the Earth's atmosphere are known as primary cosmic rays. Most of these rays are fast-moving protons or fast-moving alpha particles. Both the Earth's magnetic field and the Earth's atmosphere reduce the number of primary cosmic rays that reach the Earth's surface. Name a source of background radiation apart from cosmic rays. Rocks, soil, and the building materials, the radon gas present, all these could be written as the alternative or another way of background radiation apart from cosmic rays. The next part says state one effect of background radiation. So they can cause cell damage or cancer and mutation or gene damage. All of these could be the effect of background radiation. The next part says state the number of protons and the number of neutrons in an alpha particle. So alpha particle is like a helium nucleus. Number of protons present in the alpha particle are 2 and number of neutrons are also 2. So the mass number for alpha particle is 4 and the charge number is 2. The next part says explain how the Earth's atmosphere reduces the number of alpha particles that reach the Earth's surface. So basically the alpha particles, they are stopped by the air or atmosphere. So we can write alpha particles are stopped by air or the atmosphere of the Earth, and they are also scattered by the air, and they also slow down because they are causing ionization in the molecules of the air. Okay, the next part says figure 11.1 shows an area where there is a uniform magnetic field into the page. On figure 11.1, draw a diagram to show the deflection of an alpha particle by this magnetic field. So when an alpha particle enters the field, it would be deflected in a anti-clockwise direction. So this curve would be showing the deflection because it is a magnetic field into the page. So the deflection is going to be caused in an anti-clockwise direction. Okay. The next part says primary cosmic rays produce carbon-14 in the atmosphere. The half-life of carbon-14 is 5700 years. Define the term half-life. So it is the time taken for activity or count rate to half or the number of radioactive nuclei to half. So I'm writing the first one. It is the time taken for the activity to half. Okay, the next part says a specimen of wood is found to contain 25,000 atoms of carbon-14. An otherwise identical specimen taken from a living tree is found to contain 200,000 atoms of carbon-14. Determine the age of the specimen that contains 25,000 atoms of carbon-14. Since a living tree or a fresh specimen contains 200,000 atoms of carbon-14, so we would be starting with this number. After the first half-life, this number would reduce by half and it would become 100,000. After the second half-life, this number would again reduce, so it would become 50,000, and after the third half-life, this number would again half, So it would become 25,000 atoms. So this is the number which is given to us in the question. So it means that there are 3 half-lives. So I'm writing number of half-lives in this case, small n, is equal to 3. So the age would be 3 times 1 half-life, which is 5700 years. So the answer would be 17,100 years. So the answer is 17,100 years. This would be the age of that specimen. State why it is not possible to use the amount of carbon-14 to date a specimen that is 570,000 years old. Since the half-life of carbon-14 is 5700, if we use it to check this specimen, which is 570,000 years old, so it would not be suitable because it would be containing 10 half-lives. So there would be a very small amount of carbon-14 left in the sample. That very small amount would not be suitable for us to determine the age of this specimen. So some other kind of radioactive material should be used, which should be having a larger half-life as compared to carbon-14. The next part says carbon-14 is one of the isotope of carbon. Another isotope of carbon is carbon-12.